Okay, so we're gonna get started. I don't think anybody's here yet, based on my seeing the stats, but we'll get trying anyways. Take up some of the questions out of the textbook, section 3.2, and you can find the worksheet on the EdSpeed library. So section 3.2 is what we're looking at, and just gonna look up the questions quick. Section 3.2, we were looking at numbers 1, A and B, 2, A and B, 4, 6, and 7. So those were the key questions that we were looking at. And then in this section, we're looking at the volume of cones and spheres. So let's get started. So here we have section 3.2, volumes of cones and spheres. Sorry, my writing's a little sloppy. I'm just kind of rushing through this a little bit. A little bit behind. Okay, so volumes of cones and spheres. We have two key formulas here when we're working with a cone, which is a round base that, unlike a prism that has equal sides, it pins up to the top. And we're worried about the radius and as well the height. So the height from the base to the peak, and then the radius of the base circle. The volume is 1/3 pi r squared h. So it's the same kind of formula as cylinder, but as well has this addition of 1/3. So anytime you're looking at a cylinder, pyramid type shape of any kind, you're actually going to have 1/3 the formula of the base prism. So 1/3 pi r squared h, so 1 divided by 3 times 3.14 times the radius squared times the height. That's the first one. The second shape that we're looking at here is, and I'm terrible at drawing circles, but a sphere. I usually do a little dash line around like that just to give it the idea that it's a sphere. The only measurement we need here is the radius. Radius of the sphere are all that we need. Its volume equals 4/3 pi r cubed. So sphere, 4/3 pi r cubed. And a cone, 1/3 pi r squared h. Now, there's some of the questions we'll take a look at quickly here. So using each of these is pretty straightforward. We just fill into the equation. So it is important to note when you're looking at the worksheet questions, they do try and give you a kind of three-dimensional look to a sphere. They'll usually label it. They should label it as a sphere because it's hard to tell sometimes. I'm going to actually switch over here. So if you look here, yeah, to the right way. So if you look here, sphere, they try and give that color to make it look spherical. It doesn't really look good, especially when it's copied like this. So make sure you're reading if you're looking at a sphere or a circle, and that should help. Make sure you pick the right formula. But if you're asked for volume, then you should be right away recognize that it is a sphere. If you see that kind of weird shading, you should recognize the sphere as well. So looking at some of these questions, The questions from number 1 and 2, you're just filling in the formula and calculating the answer. So your radius is given. Make sure in 2B you pay attention that this is not the radius. 6.9 is diameter of the circle. If we continue on here, looking at 4, 6, and 7 are the word problems. Those are the ones I wanted to take a more kind of close look at. Number 4, we have a choco ball. Is a solid sphere of chocolate with a diameter of 1.8 centimeters. Determine the volume of one choco ball, and then how much chocolate will you consume if you eat a package of 12 choco balls. So if we set that up, what we can do here is number 4, part A. So we got a choco ball, its diameter 1.8 centimeters. Thus, the radius is going to be half of that. So R is going to be 0.9 centimeters. And I should probably switch that back over. Sorry. So there's number 4. 1.8 centimeters is diameter. Radius is 0.9 centimeters. So let's take that down and actually calculate the volume now. So volume of a sphere is 4 over 3 times pi times r cubed. So we'll fill that in with their values. 4, this is what you could type in your calculator here. 4 divided by 3 times 3.14 times the radius, which is 0.9 squared. Cubed. Do that, and you should get yourself the volume of the sphere, or a choco ball in this case. And I make a big mess as I reach for my calculator, but we'll pop that into the calculator. So 4 divided by 3 times 3.14 times 0.9 power of 3 equals 3.05 approximately. And then we'll round to 3.1. There was one decimal place. Question, so the volume is 3.1 centimeters cubed. Now, second part of this question had asked, how much chocolate will you consume if you eat a package of 12 choco balls? So we want to eat 12 of these. So part B, all we're doing is we're taking our volume of 3.1 centimeters cubed. We're going to multiply that by 12. When we multiply that by 12, we get 37.2 centimeters cubed. So that there is our volume, the actual physical mass of chocolate that is in our stomach if we ate 12 of them. Might actually be useful to convert this one to liter measurement. So in liters, 37.2 divided by 1,000, and there are 1,000 cubic centimeters, remember, in a, so 1,000 cubic centimeters in a cubic liter. So we'll divide that by 1,000 at 0.0372 liters, which is going to be 37.2 milliliters. So that's 37.2 milliliters of chocolate in our stomach, because it'll probably be in liquid form by the time it gets belly. So that's number 4. Just plug in values in, and then for part A, and in part B, looking at a volume of or an additional mass of 12. So you're just adding on some extra stuff in there by multiplying by 12. Taking a look at number 6. In the case of number 6, have transitioning that. Number 6 says, suppose that a zoo, question 5. Oh, sorry. So number 6, you actually have to do number 5. I should have probably assigned number 5 as well. Let's take a look at number 5 first, then we can do. Number 5 says a petting zoo allows visitors to feed the animals grain from paper cones. I remember doing this with Greenland down in Niagara Falls. You got to feed the deer out of a cone, and they would try and eat your clothing if you did right away. I walked out of there with holes in my shirt when I was a child. But anyways, how much grain in cubic centimeters will fit into a cone with a diameter of 6 centimeters and a height of 8 centimeters? So in this case, part A, we're looking at the volume of the cone, how much is going to fit in there. So in part A, had a volume equals 1/3 pi r squared h. So we have 1 divided by 3 times 3.14 times our radius of the cone is 6, diameter of 6, so radius of 3 centimeters and squared, times the height, which was 8 centimeters. And so now I'll multiply this all out and divide as needed. 1 divided by 3 times 3.14 times 3 squared times 8. That's going to give me a grand total of 75.36. And again, 1 decimal place in the question, so I'm going to put 1 decimal place in my answer. 75.4 centimeters cubed. So we get 75.4 cubic centimeters in our cone of grain that we can fit. In part B, it says that Billy the goat usually eats 500 cubic centimeters of grain for lunch. How many times will Hoshi need to fill her cone in order to give Billy his lunch? So in part B, we are needing 500 cubic centimeters. So 500 divided by 75.4 going to get us the number of times we have to fill that cone. 500 divided by 75.4. It's going to get us about 6.63. And probably filling our cone, we're likely to fill this up all the way each time. So we're going to round that out to 7. So you're going to have to fill that cone 7 times. Now we can do part 6. And if we go back to questions here, number 6 says, suppose the zoo in question 5 allows animals to be fed wonder pellets, which are just as filling as regular grain. Each sphere-shaped pellet has a diameter of 3 centimeters. Determine the volume of one pellet, and then how many pellets will Billy typically eat for lunch. Switch that back over. So we got we need to find a volume given a diameter of 3 centimeters. So volume, now there's spherical pellets. You have 4/3 pi r cubed, filling that in, 4 divided by 3 times 3.14 times the radius of the pellet, and again the volume or the diameter of the pellet was 3, so the radius is half of that, 1.5 cubed. Plug that into your calculator, and we get 14.13, or rounding 14.1 cubic centimeters in a cube, or sorry, in one of these spheres. And so now we want to know how many of the pellets that Billy would typically eat for lunch. And so Billy typically eats the 500 cubic centimeters, so we just divide that by 14.1, and when we divide that out, we get 35.46. So he'd probably eat about 36 pellets approximately for lunch. So that would be question number 6. And then the last one is question number 7. Just looking at a French fry package. Wrap this up. Number 7 says Farouk's French fries. Back to the right screen here. So Farouk's French fries come in cylindrical container for $3, while Charlene's, I think I'm not good at pronouncing names. Charlene's chips come in a cone-shaped container for $1.50. Who offers the better deal, and what assumptions must you make? All right, so let's take a look at that. Back here. So in the case of part A, we got Farouk's French fries coming in a cylindrical container for $3, and Charlene's chips coming in a cone-shaped container. Who offers the better deal? Well, assumption, we should probably start with our assumption. What do we got to assume here is that we're probably looking at the same top sphere of chips. So the top radius on the cone is likely the same as the cylinder radius. And so as I mentioned earlier when we were talking about the actual formulas, the formula for volume is 1/3 pi r squared h, and then the volume here is pi r squared h. So assuming the same height, the same radius, then the cone is actually 1/3 of the volume. And if we go 1/3 of the volume, then the cone is going to give us 1/3 the amount of chips. And so 1/3 the price of $3 should be 3 times 1/3, or $1. Okay? So $1 would be the accurate price for that conical amount of chips compared to Farouk's. So Farouk's actually selling at $3, and you're getting 3 times as much chips versus $1.50, where you're getting 1/3 of the chips. So your better deal comes from Farouk in this case. Slide so you can actually see the dollar. So that's my general idea of how I would kind of approach that question. That covers all the questions for today. Again, if you need some extra help on any questions, make sure you send me a message through Edsby email, and I can help you out with those. All right, you guys have a good day.